All right, so today we are doing verifying inverses with composition. So if you remember from last class, we did composition of functions. Now we're going to use composition to verify or check if functions are actually inverses. Okay, so what I mean when I say that is if I give you two functions, say I gave you, so if I gave you f of x equals 2x minus 4 and g of x equals 1/2 x plus 2, and I asked you, are they inverse functions? Okay, well, we're going to look at one way to verify if they're actually inverse functions or not. And to do that, we're going to use composition. So there are multiple ways that you can verify, but the way that we're going to look at right now is by using composition. So if you remember from last class, we said that if you have f of its inverse function of some value, some number, okay, we'll just say x for right now, what would happen is that the function and its inverse function, since they're opposites, they end up canceling each other out, right? And all we are left with was x, or let's do it with a number. We had f of the inverse function of f of 4. Okay, what would happen is that the function and its inverse would cancel out, and your answer is simply 4, right? So that's what we're going to use to verify if these functions are actually inverses of each other or not. Okay, what we would need to happen is we would need everything to cancel out except for x, right? So what that means is that we need to take f of g of x, and the f function and the g function, if they're inverses, would cancel each other out, so that we would just be left with x. Okay. Additionally, we could do it the other way. G of f of x, the g function and the f function need to cancel each other out, so that we're just left with x. Okay. So this is what we're going to be doing, right? So let's look at this first example. Here are two functions. Okay, so if we want to figure out are they inverses, we're going to use these methods. Okay, technically you should do both. You should do it this way, make sure it equals x, and do it this way, make sure it equals x. With linear functions like this, if it works for one of them, it'll work for the other one. Okay, I am going to do both just so you can see, but with linear functions like the examples you're being given, where x is just raised to the power of 1, if it works for one of them, it will work for the other one, vice versa. Okay, so let's solve it using f of g of x first. So f of g of x. All right, so what that means, first thing we're going to do is we're going to replace, oops, I forgot my parentheses. We're going to replace g of x with what it's equal to. Okay, see how I brought my f down? And then I'm going to replace g of x with what it's equal to, which is 1/2 x plus 2. Okay, that's my first step. Now I want to actually solve this. Okay, so I want to take that, and wherever I see an x, I want to plug in this whole thing, 1/2 x plus 2, into my f function. So f of x, right, we're replacing our x with everything inside this parentheses, 1/2 x plus 2. So I'm going to bring down my 2, and then in parentheses, I'm putting a 1/2 x plus 2, and then I'm bringing down my minus 4 on the outside. So basically what we did is we took this g of x function, the 1/2 x plus 2, and we plugged it in to the x of the f function, right? So we have 2 times my g function, and then our minus 4, okay? And then we're going to simplify from there. That's all we're doing. Right, so 2 times 1/2 x. If we distribute, right? 2 is the same as 2 over 1. If you're multiplying by 2 and dividing by 2, that's 1, right? So we have 1 over 1, which is just 1. I'm going to come down here. So we have 1x. You don't have to put the 1 in front if you don't want to. And then 2 times 2 gives us a positive 4. And then we bring down our minus 4. We're still simplifying. We have like terms right here. So we have our x, and then 4 minus 4 is 0, right? They cancel each other out. So we're left with just x. So we got that f of g of x equaled x, which means our f function, our g function are inverses of each other. The way they like to write the answer is they would say yes, they are inverses because y equals x. Okay, why? Why did they put y and not f of g of x? Because f of g of x is the same thing as y, right? This is just y equals x. They don't always have to use f and g. They could have h or k, whatever variables they use to name each function. But those variables always mean y, okay? So yes, because y equals x would be our answer. So up here we checked it using f of g of x. Now down here we want to check it using g of f of x. Like I told you, you do not have to do it both ways like we did f of g of x and now we're doing g of f of x. You don't have to do it for both when we're doing linear equations, but if we were doing any other type of equations, you would need to verify that it works for f of g of x as well as for g of f of x. Okay, so let's try it. So if we're doing g of f of x, that means we're gonna have g of, and then where I had f of x, I'm replacing f of x with what that function was equal to, which is 2x minus 4. Okay? Which means in my g function, wherever I have an x, I'm plugging in the f function. So I'm going to have 1/2 times 2x minus 4 plus 2. Okay, so my g function, let's rewrite it so y'all can see. My g of x function equal to 1/2 x plus 2, and f of x function equaled 2x minus 4. So what we did is we put our f of x function in the middle. We basically took f of x, what it was equal to, 2x minus 4, and we substituted it in for the x value of our g function. Okay, see how we did that? We kept the 1/2. Where the x was, we replaced it with our f function, 2x minus 4, and we brought down our plus 2. And now we're going to simplify. Half of 2x, so 1/2 times 2, multiplying by 2 and dividing by 2 leaves us with just 1x. Half of a negative 4, you would have 1 times 4 on top, which would, or negative 4, which would be a negative 4 over 2 times 1 on the bottom. And then we bring down this plus 2. Negative 4 divided by 2 is a negative 2. Bring down our plus 2. Minus 2 plus 2 is 0. So we're left with just x, which is what we wanted. So yes, they are inverses because y equals x. Another way you could verify if functions were inverses or not is by looking at the graph or looking at their table. Okay, so if you look at the functions that I put in on Desmos.com, I typed in our function f, our function g, and then this is what they should reflect over. Remember, this is what we should get. Everything should cancel out but x, right? So we should end up with y equals x if they're inverses of each other. So they should reflect across that green line. if you look, they definitely reflect across that green line. If you turn it to the side, you can see that the red function and the blue function reflect across the green line, the function y equals x, okay? One way you could also do it is with points. So if you look on our red function, we have the point 2, 0 right here. So if you flip to 0, it'd be 0, 2. If we went to 0, 2, we end up with a point on our blue function. Okay, let's look at another example. This one says, are these functions inverses of each other? And it gives us the function f of x equals 2x plus 3 and g of x equals x plus 3 divided by 2. So we're going to check it both ways. All right, we'll do f of g of x, and we'll also do it g of f of x. So for f of g of x, really what we're going to do is we're going to take this g function, what it's equal to, and we're going to substitute it in where the x is in my f function, right? That's essentially what we're doing. So step 1, you're replacing g of x with what it's equal to, which is x plus 3 divided by 2. And then you're plugging this in for the x values. So essentially a shortcut would just be to go ahead and plug your g function into the x value for your f function. So we get 2 times, instead of x, I'm putting my g, x plus 3 divided by 2 plus 3. Okay? And then all you do after that is just simplify. Okay, so to simplify, we have 2 being multiplied by our parentheses. Multiplying by a 2 and dividing by a 2 cancel each other out, so that all you're left with is x plus 3. And then we bring down this plus 3. We're going to combine like terms, so plus 3 and a plus 3 gives us x plus 6. These aren't like terms. I can't simplify any further. This is what I'm stuck with. Didn't end up with I didn't get just equal to x, right? I got equals to an x plus 6. So these are not inverses. You would still get the same result even if you chose to do g of f of x. If I did g of f of x, then I'm plugging my f function into the x value on my g function. So I would have g of 2x plus 3 as I'm plugging the f function into the x of my g function equals, so where I have an x, I'm putting f, I'm putting the 2x plus 3, and then I'm bringing over my plus 3 and divided by 2. So up top here we have 2x plus 3, which gives us 2x plus 6 divided by 2. Okay, this does simplify. Oh, I lost my pencil. All right, so it does simplify. 2x divided by 2 would give us 1x, and positive 6 divided by 2 would be plus 3. Once again, we don't end up with it just equal to an x, we end up with an x plus 3, where here is x plus 6. Either way, these two functions are not inverses, and we would say because y equals x plus 3. That's why they're not inverses, because y equals x plus 3. Or over here, they're not inverses because y equals x plus 6, right? In order to be inverses, we needed y equals x. They're not, because y equals x plus 6 or y equals x plus 3. Okay, we're going to look at one more example. We have f of x equals 2x plus 6 divided by 3, and g of x equals 3 halves x minus 3. Okay, so we want to verify if they are inverses or not. So we'll do it. Let's do g of f of x first. Does it matter? Absolutely not. Okay, so if I'm doing g of f of x, that means I'm putting the f function in for the x value of my g function. So I'm going to have g of 2x plus 6 divided by 3 equals, and I'm putting my 3 halves, and then where x was, I'm putting my f function, 2x plus 6 divided by 3, and then I'm putting my minus 3. Okay, from there I need to simplify, right? So one thing I can go ahead and see is that multiplying by 3 and dividing by 3 would cancel each other out. So then I'm left with a 2x plus 6 divided by 2 minus 3. Then I can see this can simplify because 2 is divisible by 2 and 6 is divisible by 2. So I would have 2x divided by 2 is 1x, and positive 6 divided by 2 is a plus 3, bringing down my minus 3. Combining like terms, a positive 3 minus 3 would cancel out, so we're left with just x. So yes, because y equals x, right? G of f of x is just y. So we end up with y equals x. So they are inverse functions. Okay, so if we were to do it of f of g of x, then I'm plugging in the g function into the x value of my f function. Okay, so we would have f of the g function, 3 halves x minus 3, equals, so we're using our f function, so I'm putting this 2, and then where x is, I'm putting my g function, so I'm putting 3 halves x minus 3, and then I'm putting the plus 6, and the whole thing is divided by 3. Okay, oops, sorry. So we want to double check this, or we want to simplify this, sorry. So we want to do 2 times this, where we have multiplying by 2 and a dividing by 2, so those two would cancel each other out for this first function. So we're just left with a 3 times x. And then if we distribute 2 to the negative 3, 2 times the negative 3 is a negative 6, plus 6, all divided by 3. Well, a negative 6 plus 6 is 0, so then you're left with a 3x divided by 3. And multiplying by 3 and dividing by 3 cancel, it's just 1, so we're left with 1x. So back to our answer of yes, they are inverses because y equals x.